Okay, grade 7, this is your 2018 Circle Chapter 8 final test. This is May 10th, 2018. Your first questions on this test are all your true-false questions. I think there was 5 of them. So pay close attention as we do these. If you made a mistake, just kind of internalize what it was you did wrong and make the corrections and pass them in when we do it. So if you didn't get 100%, all of y'all right now are watching, and all of y'all are got a pencil in your hand, and all of y'all are making the necessary corrections as we go through these. Okay, here we go. Okay, your first question is a true-false and says r squared is the same thing as your diameter. And this is false, and here's why. If you look at a circle, that's the radius. So the diameter is really 2 radiuses, and r squared does not, 2 radiuses is not the same thing as r squared. Because, for example, if the radius was 5 meters, then this would be 2 times 5, which would make the diameter 10 meters. But if I took that same 5 and I squared it, I don't get a diameter. I get a completely different number. I would get 25 in that case. So in this case here, the main thing you have to realize is that 2 times the radius, which is really the formula for diameter, 2 times the radius is not the same thing as squaring the radius. Okay, a completely different concept. So your answer is false. Question 2 says the circumference of a circle is approximately 3 times the length of its radius. So if I take a circle and I randomly put down a radius of, let's say, 10 meters. Okay? So the circumference formula, circumference equals pi times diameter. That's your formula you need. So circumference would be equal to pi, which is approximately, we'll say 3 because we're estimating. And the diameter, if the radius was 10, the diameter in this case would be 20. So the diameter is 20, the radius is 10, and the circumference for this one would be 60 in this particular example that we did. So if we look at the circumference being 60, and we look at the radius as being 10, the circumference is not 3 times the length of the radius. The circumference is approximately 3 times the length of its diameter is one way to correct that to make it true. So the answer is false. It's not true. This would be true, what I wrote there. Or you could cross out this 3 and put the number 6. So the circumference of a circle is approximately 6 times the length of its radius. That's true. But the statement that was made, the circumference of a circle is approximately 3 times its radius, is a false statement. Question 3, pi is equal to the circumference times the diameter. Well, that's false, because we learned that pi, as a formula, is any circle's circumference divided by its diameter will always approximate pi. And we learned when we did the bike tire, and when we did my mug, and when we did the CD, and when we did the clock, we didn't get an exact pi when we divided what we measured as its circumference by what we measured as its diameter. But in all the instances where we took a circle's circumference and took a circle's diameter and we divided them by each other, we got 3 point something, always approximating that pi value. And question 4, r squared, just like the first question, r squared is doubling the radius. So r squared doubling the radius would really be multiplying by 2. When you double something, you really multiply by 2. So r squared does not equal doubling the radius, and therefore, just like the first question, it's a false statement. In question 5, your last of your true false, it says the number that represents the area for this circle is the same as the number that represents the circumference. So what you needed to do here was you needed to write your 2 formulas. So area, we know that it's pi r squared, and circumference, you should know it's pi d. If you didn't know that, it was on the wall up top there to the left of the whiteboard. You could actually see it up there, and you would be able to use those formulas. So using pi as being 3, because we said that it doesn't matter what we use. The more accurate your pi is, the more accurate your answer is. But we don't need accuracy. We just need an approximate value. The diameter is 2, so we'll square that. And pi over here, or sorry, the radius is 2. And in this one, if your radius is 2, Your diameter, which is your d, is 4. So 3 and 2 squared is the number 4. I'd have 12 meters squared for the area. And over here, 3 times 4, I'd have 12 meters for the circumference. And both of those numbers are the number 12, so therefore your answer is true. Both of the numbers that represent the circumference and area are the same, but they're not the same thing at all. They just happen to be the same number. One's in square units, and one's in distance units, meters. Question 6. It says, what is the approximate circumference of this circle? So we have to use circumference is equal to the pi multiplied by the diameter. In this particular circle, there is no diameter given, but we do know the radius, which means if I was to draw a diameter, 4.5 doubled would make that diameter 9 centimeters. So 3 times 9 is 27 centimeters as the approximate circumference of the circle. In question 7, this is what is the approximate circumference of this one's a little bit easier this time because your circumference is equal to pi times diameter, but this time the diameter is actually given to you as being 10, so therefore it's simply pi 3 times 10, which is approximately 30 meters as its circumference. In question 8, what is the approximate area of this circle? So area of a circle is equal to pi r squared. 3, the radius is given as 4 and squared. And you got to remember that once I write my formula, pi r squared, and I substitute the numbers that I know, pi being 3, r being 4, and squared, I now have to simplify it using bedmass. Now, B, E, D, M, A, S is what bedmass is, and there's 4 steps. There's B for brackets. Now, these are not brackets in the sense of bedmass. Brackets would look more like this. If I had 2 plus 3 take away 5 multiplied by 4, inside these brackets there is an operation for me to solve, and I'd have to do that first. Those are brackets for bedmass. These are brackets because I want to separate the number 4 from the number 3, and I also want to show that there's multiplication in here. So the brackets are there for a different reason, not to do these first. So once I have that, my next letter in bedmass is E, and it stands for exponents. And it's the first time in your mathematical experience that you've used exponents in order of operations, r squared. But when I have that, I have to go 3, and then I have to square my radius. And 4 squared means 4 multiplied by itself twice, once and twice. So the 2 is how many times you multiply 4 by itself. If it had been cubed, a different formula, 4 cubed, we would multiply 4 by itself 3 times, and we would get a completely different number. But for grade 7 math, we just have squares. So it's 3 times 16, which is 48 centimeters squared. And the next one, this is question 8. What is the approximate area of this circle? So we have to use our formula, pi r squared for area again, or 3. Now this time the radius is not given, but if I know the diameter, I can infer that the radius would be half of that, which is 7. I'd have 3 times 49. Now mentally I can do this because I can do 3 times 50. 3 times 50 is 150. So 3 times 49 would be 3 less than 150, which is 147. Meters squared. My mistake, that was question 9. Question 10 is your table here. I'll write it backwards. Hopefully you can all read backwards. That's question 10. And it gives you one of the things, and you're supposed to give the other 2. So for the first line, if the radius is 1.5, so I would take the first line and I would put my radius at 1.5, and I'd list my diameter as being double that, so it's 3 meters. Once I have my circle for, we'll call this A, we'll call this B, we'll call this C, and we'll call this D. This is A's picture. Once I have that, in order to get the area for that picture, I have to use area equals pi r squared, pi r squared. It's a little bit difficult because I actually have to use a calculator for this one because I don't know what 1.5 squared is, but I know that it's 1.5 multiplied by itself is 1.5 squared, which is 2.25. So I have 3. Instead of saying 1.5 squared, I can say 2.25 because that's its value. Multiply that by pi, and I get 6.75 meters squared as its area. Now for circumference of the circle is another formula, pi d. So 3 multiplied by what I already know the diameter to be, which is 3. And therefore, the diameter of this circle, the circumference of the circle, would be 9 meters. And notice the work I showed. So I have a picture, which is probably important for everybody to show. I have a formula for area. I have a formula for circumference. I substituted in both of those formulas, and I simplified. And the one that most of you forgot was to put proper units in there, meters squared and meters. I didn't take marks off if you didn't have meters squared or meters or proper units. But everything I wrote here for A is what you should have shown me as work, right? You should all be capable of doing that. You should be able to show me that work. Okay. The second one, B. Scroll down just a little bit. So my circle will look like this for B. I know the diameter is 5, which means the radius will be 2.5, I think. Yeah, that's the one. So again, for area, I'll use pi r squared, or pi times the radius squared, or pi times 2.5 squared, which is 6.25, which would be 18.75. I think it's meters. Is it meters or centimeters? It's meters. Meters squared is your area. Formula, substitute, simplify, answer, proper units. For circumference, pi times diameter. We've already figured out the diameter is 5, so it's going to be pi times the diameter, or 15 meters as your units for circumference. So that's the answer for B. Question C. You're given nothing. You're given a circle, and all you know is the area is equal to 21 meters. So here's how we're going to, or meters, would I have that backwards? The circumference for that one? That's the circumference. I got these backwards. Hang on one second. This one should be over here, and this one should be over here, and this one should be deleted. Delete, no, yeah, delete that one, and delete this one. There we go. That's right, right? Okay. So for the third one, the circumference is 21. So what I'm going to do here is I'm going to write my formula. Circumference equals pi times diameter. I know circumference is 21. I know pi is 3 approximately, but I don't know my diameter because there's nothing written in here. But look, when I substitute what I know, I end up with an algebraic equation, and it's a one-step. All I have to do is divide both sides by 3, and I'll isolate for the diameter. 21 divided by 3 is 7, and therefore the diameter of this circle is 7 meters. And once I know that, then I know everything else about my circle. I know that the radius is 3.5 meters, half the diameter. And I know that in order to get the area, I use pi r squared. Or pi times r squared. Or pi times whatever 3.5 is, squared, is 12.25, which is 36.75 meters squared for area. 36.75 meters squared. Okay. Any questions so far? We're good? Ja, ist gut. Ist gut. Yeah. Pass. Question D. So this time I'm given my area. So I'm going to have my circle again. I have my I don't know the diameter. I don't know the radius. All I know is the area is equal to 108 meters squared. That's all I know. So I take my formula, area equals pi r squared, and I substitute area, which is 108, equals pi, which I know, r squared. So 3 times something had to give me 108. 3 times r squared, or 3 times something had to be 108. So if I divide to get rid of the coefficient, I end up with this. R squared equals, what is it, 36? That's what I do if I use my basic algebra. I get 36 equals r squared, or 36 equals the radius times itself. And the only thing the radius can be, and you haven't learned this until grade 8, r has to be 6, because 6 times 6 is 36. In grade 8, you're going to learn that you'd square root both sides, and you get the same answer. But therefore, I know the radius is 6, which makes the diameter 12, which makes the circumference 36 meters. Point. Mr. Trevor Bridges has a semicircle shaped yard. He wishes to build a fence around his property. If I had a nickel for everyone that got this wrong, I would make a lot of money from all of y'all. Because you couldn't figure this. Only 3 people in this whole class did this question perfectly. And here's what you had to do. So if it's a property, all of what I just did in black is his fence. Okay? So this part in red is really half the circumference of a circle. So if I take circumference equals pi times diameter, and I realize the radius is 8, which makes the diameter, this distance right here, 16 meters, then the full circumference of that circle would be 48 meters. But I don't have a full circle. I have a half circle, which means that the semicircle would be half of that, which makes this distance here 24 meters. The problem is, 3/4 of you forgot that this is also part of the fence, which means I have to add another 16 meters to his property, which makes the distance around his property, or the fenced distance that he needs to do, as being 40 meters, and that's the answer. 40 meters of fence is required to build it around his property. If you take $82.50 per meter of fencing and multiply it by the 40 meters of fencing he needs, you end up with $3,400. Is that right? $82.50 times $40 is $3,300. And that's your answer for that. The next question is, a circulating lawn sprinkler can rotate 360 degrees. So I'm going to put a sprinkler here. It can throw water 3.8 meters. So in all directions, 3.8 meters, 3.88 meters in all directions. Which means that 3.8 meters is really the radius of a circle. So there's your picture that kind of shows it. It's kind of messy, but whatever. And how much area can it cover? So area equals pi r squared, or 3 times 3.8 squared. Taquez-vous mon calculator and find out what 3.8 squared is. 14.44. Multiply that by pi, and you get an area of lawn of approximately 43.32 meters squared of area it can cover. And your second last question was this circle, and it says, given this circle, tell me how many degrees A is, what percent X is, what degrees are Y, and what percent is Z. So the first thing is this one here, A squared. Now we know that a circle is 360 degrees, which means that A, being a straight line and half of a circle, is going to be half of that, or 50% of 360 degrees, which makes the number of degrees for A 180 degrees, or a straight line. The next part, if this sector of, or this, I guess segment of a circle, this piece of pie, is 36 degrees, which means if the whole circle is 360, then it must be 10% of 360 is 36, so therefore it represents 10%. And if this is 10%, and this is 50%, sorry, 10%, and this is 50%, then this is all 60%, which means the remaining part has to be 40%. And since each of those is equal, they must both be 20% each. If it's total 40%, but both of them are equal, each of them must be 20%. And if 10% was 36, then 20% of 360 would be two 36s or 72 degrees each. And your second last question says a ring has a thickness of 3 meters. What is the area of the ring? So for this one, if I take my picture and I ungroup all these things. Oh, can I do that? I can't. It won't let me. So if I think of this red circle here, I'll make a red circle because I can do that. If I make this red circle here and ask you, what is the diameter of the radius of the red circle, you would say it's 8 meters because this is 5 and this is 3, so the radius must be of that red circle 8 meters. So the area of this one is 3 times 8 squared, or 3 times 64, or 192 square meters. But that red circle is not a red circle. It has this big white circle cut out of it to make that red ring. So if I figure out what was cut out, it would be 3 times 5 squared, or 3 times 25, or 75 meters squared was cut out. So the answer to the question is, if I take my full red circle and subtract the white circle that was cut out, I end up with 117 meters squared as the remaining area of the red ring. And that's your answer. And finally, the last question, a red square had an area of 36 meters squared. A circle was cut out of the square as shown. What is the area of the remaining square? So if I take this red square, which I can make because I have the power to do so, and I redraw it here like this, and put it right there. That red square had an area of 36 meters, which means each of these must have been 6 meters to give it an area of 36 meters. And if this length here is 6 meters, then this length here is 6 meters, which means the diameter of the circle is 6 meters, which means the radius is 3 and the diameter is 6. The area of the white circle will be pi r squared, or pi r squared, or pi r squared, or 27 meters squared. If the area was 36, but I took away a 27 meter squared circle, that means, sorry, is that right? My math right? Yes. The remaining red must have a total area of 9 square meters.